so just to double check, tangent 5 pi over 3, which was 300. Is indeed negative, so just want to make sure I don't mess up somewhere. I just left off the negative. Okay. On E, we do like we normally do. Plug in -2. Okay. So what are you getting?
0 over 0.
Okay, 0 over 0, which we said technically cannot equal that. Now that doesn't mean that the limit didn't necessarily exist. What did it mean? Yeah, it means that we have to do something else. It could be a hole or a hypotenuse. A hypotenuse, you mean an asymptote. I knew what you meant. Yeah, there's some issue.
Can we do anything?
Yeah, what else can we do? Well, we did that.
We factor things.
Factor, yes.
Factor thing, that's a thing.
If we factor the top, remember to multiply, give me -6. 2 and 3, I heard. Which one's positive? Which one's negative?
-3.
And then what can we factor on the bottom?
2.
Leaving us with x plus 2. Oh, so what happens?
Okay, I thought the 2, you couldn't do that.
No, we're canceling the whole thing.
Okay.
Not just the 2, the x plus 2. As long as it's
Well,
multiplied.
let's take the 2 in front of it.
Oh, no, that's okay because it's multiplied. Now, if it was 2 plus that, no, we couldn't. So we're left with x minus 3 over 2. Now we plug in -2. So -2 minus 3 over 2. It's -5 over 2.
I just say it could be a different answer.
Well, because what has happened is when you have something that cancels out here, it creates a hole in the graph. So, you know, I've got this going on here, whatever it is. And when they cancel, it created that hole. And when I try to plug it in here, it gives me an error because there's not an actual point there. But there is still a limit at that point, which is why this works. Excellent question. Okay.
Is there any way to tell that there's a hole, like right off the bat?
What? No, other than factoring and seeing what cancels, because that's what causes the hole. You'll get quicker at it, plugging things in your head and that kind of stuff. Okay, you tried this one. Yeah.
What if it doesn't factor?
Yeah. What if? There's other things we could try.
Well, wait, question. If it's like a number over 0, isn't that infinity?
Oh, yeah. Yep, sure is. Remember we talked about learning how to divide by 0? Okay, sounds like y'all are either getting to a point where you're stuck or figuring out what to do. So if we plug in 3, I get 8 over 0. So this positive number divided by 0 is, let's see here, is indeed infinity. However, it might be a negative infinity from one side and a positive infinity from the other side, right?
Mm-hmm.
So if I plugged in x as approach 3 from the left-hand side, on the top, it's always going to give me 8. But on the bottom, yeah, it's going to give me a negative. And then if I did as x approaches 3 from the right, that one would give me a positive. So not infinity, I should put does not exist.
But there's a vertical asymptote.
Yes, it is a vertical asymptote. And what's going on in that vertical asymptote is to the left of it, it's going down forever, and to the right of it, it's going up forever. And all that we can tell just by plugging things in without actually having to graph it. Okay, for the next one, we're going to plug in 3 over 2. Okay, so notice I changed those. Those are not really equal then, because you can't have it equal 0 over 0. So that means I should try something else. Yes, it does factor. This is the one that most of us probably don't remember the rules to. You could do it the long way, the long division way. You probably don't remember that either. So it is, both of these are cubics. So what number can I multiply by 8, or by itself 3 times to give me 8? 2. So that's 2x. And what can I multiply by itself 3 times to give me 27? 3. And then what's left, you take the 2x, the first part here, you square it. You change the middle sign, and you multiply those two together, so that's 6x. And then you square the last one.
Multiplying which two together?
2x and 3, but you change the sign to a plus. I will write down the rule here for you. If you have a cubed minus b cubed, it changes into a minus b, and then a squared plus ab plus b squared. If it's a cubed plus b cubed, it's a plus b, a squared minus ab plus b squared.
Okay, so it's positive for 2 different sides.
Yes. Then we can see the 2x minus 3's cancel. So that creates a hole in the graph. And what's left is just 4 times 3 over 2 squared plus 6 times 3 over 2 plus 9. I think it's 27, yeah. We've slept since then, but we have done one like H. We, of course, would start off by doing what? Plugging in the negative 2, so go ahead and do that. What do we get?
0.
Daniel sounds defeated. 0/0.
It's all it's been recently.
I know, right? It's the indeterminate form, which means you have to do more. Now, we can't factor this.
No.
But we did something before. Does anybody remember? What? Conjugate. Yes. Yes. We rationalized the numerator. We did this back in our notes.
We did.
We did. It was last week. Right here.
The next one gave us more space.
Yeah, I've noticed that.
So, square root of 2x plus 5 plus 1. And multiply that on bottom as well. Square root of 2x plus 5 plus 1. I can make it bigger. So you can see it. Now on top, that's the difference of 2 squares. So I'm just multiplying first times first, which if you have square root times square root goes away. And then -1 times 1, so it's -1. On bottom, just leave it like it is. Okay, so on top, I end up with 2x plus 4. Yes, we can factor the top. So what?
The bottom's just gonna stay like that.
Yeah, bottom's going to be funky, except for there's something I can do right here. There's something the same on top and bottom.
2x.
Yeah. Just the x plus 2. That'll cancel. So that leaves us with 2 over the square root, 2x plus 5, and then plus 1. Now I can plug in -2 and I should get an answer. Oops. -2. That's 2 over square root of 1 plus 1. All that for a 1.
Cute.
Did you say cute? I love it. It is cute.
I mean, at least the whole number. Why would you give you all this to get a measly 1?
Well, at least we didn't end up with something really funky looking.
We went from
Y'all would
0
grind regardless. I don't
we
even
went from
know.
0 to 1.
Okay, you try the next one. It's the same concept.
So it's gonna be 0 over 0.
Maybe. You have to check it out and make sure. Otherwise, you do a lot of work and you didn't have to.
That word's still down.
While you guys are working on this, I want to let you know day 3 homework is now very doable. There might be a couple that you can't do just because we have like a couple more problems to do. But for the most part, you should at least be able to get a real good start on it. Tomorrow we'll finish up and move on.